I have watched so many YouTube videos about AI, read articles and books, but still, if someone were to ask me, do I know about it well? I would say, nah. And that is exactly what everyone seems to say about AI, right? They're saying that it is mysterious. Even the artificial intelligence itself says that it is not comprehensible. The way it works is just beyond us. The creators don't know about it. And I think that is exactly where we must start our conversation for today. The whole story of artificial intelligence lies in just one simple thing. How is the next word predicted by these AIs or language learning models? Let us assume that this is the prompt that we have given to the system, that we want a chocolate recipe. Now the system looks at this prompt in terms of tokens. What is a token? Every single basic element of this prompt is a token. A word, the punctuation marks, and if there are any emojis that you have used, those are the tokens for the system. Now what it does is it takes every single word in sequence and creates or generates a list of numbers corresponding that particular word. What could this list of number mean? So for example, let us assume that we are talking about the word chocolate. So all of each and every single particular word explains what is the characteristic of this particular word. So a chocolate, is it a noun or not? Then is it sweet or not? Then what is the color? So if we are talking about dark chocolate specifically, so color. And if in general we are talking about a food, so each of these is a parameter, and how much close or how much far away from this particular characteristic this word is exactly what these numbers represent. So minus 7.57 could say that the number is far away from being sweet, it is sour or something like that. The number 0.1 could represent something and something else. So these numbers actually are parameters representing the characteristics of this particular word, and accordingly for each token in the prompt a particular vector, these are called the vectors, a particular vector is produced so as to understand that word more well, right? Now as we get more and more of these particular vectors, we form what we call, the system actually forms what we call as an attention. This attention corresponds to that particular thing in our prompt or in the response that the system or that AI has to focus on while answering. For example, here the focus word is chocolate, so the AI has to specifically focus on the recipe of chocolate, right? So what would its attention here be? Recipe of chocolates. So it produces this attention based on the prompt. And how does it do that? Now that is something which is very interesting. How is this attention created, and how based on these vectors of different vectors we create a prompt or response. So let's get into how the AI teaches itself, or how the AI becomes, artificial intelligence, an algorithm becomes artificial intelligence. So first of all, we'll understand how this happens. Okay, see, an AI is nothing but a code, and it had to do something that would transform the words that it has seen, right? So for example, if it has seen Paris, and if it had seen the language, or the sentence that Paris is the capital of, so now it had to predict France. How it would do that, from some words it had to go to some other words and then find out the meaning. That was the biggest challenge. And in this, a beautiful little thing in mathematics was used called the matrix. And how these matrices worked, so basically these matrices are just collection of numbers. These are the columns and these are the rows. Now, at each particular place, there is a number. At the very beginning of creating a language learning model, an efficient language learning model, these numbers are generated on random. They are genuinely just any number that you could think of, right? So this matrix, what it does is it takes this list of numbers, this list of numbers regarding that particular word. For example, it heard France, and we had a vector corresponding, or a list of numbers corresponding France. Now we wanted the language learning model to predict the next word. For that, what it did was it took these numbers, this whole list, and it multiplied this matrix. There is something like this happening in mathematics, that we multiply a matrix with, we could multiply a matrix with a vector. So we multiply the matrix with this particular vector, which also generates, this multiplication produces for us what we call as another list of numbers and another vector, right? But this vector is something different from this previous one, and now this particular vector corresponds to the probability distribution of each and every single word in the vocabulary of the language learning model. Now this is something very crazy. So basically what happens is, we have a matrix, we take the characteristics vector which has various values for the characteristics of a particular word, we multiply this matrix by this particular vector, and then what we get is another vector. Now this last vector that we obtain is specifically designed in a manner that each particular value in this vector, the first value, the second value, the third value, and so on, would correspond to each particular word that the vocabulary of this language learning model stores. So basically, if at first it stores apple, then it stores banana, then it has the word stored cat. So the first value would correspond to this particular apple, the second would correspond to banana, the third would correspond to cat, and so on for the whole vocabulary. So if there are 50,000 words in our language, yes, it would correspond to these 50,000. There would be 50,000 numeric values for this particular word that we are generating now, right? And what we do is this, what this value actually here demonstrates is the probability. How much likely is this next word to come after this word that we had? So what it does is say apple is 0.1, banana is 0.2, cat is 0.5, and we had Paris, which was 0.85, and this was the highest number in this whole vector. Then the system, or the AI, would predict what? It would predict that the next word is Paris. Amazing. Now, what it does, so it was trained, right? It was trained on millions and gazillions of data that it had. So what it did was that it saw a word from this whole data. Say there the data had many sentences. It took the first sentence and saw the first word. Now it tried to predict the next word using this whole method. If this next word that it predicted came out right, then it appreciated this list of, or this combination of values in this matrix. If it so happened that this vector or this matrix produced something, a word which is like electronic, so there is no relation. It is absurd to say France, electronic after France. So there is no relation. So now there is a system which is mathematical and uses very complex functions, which tells us the loss, that is how much different is France, say Paris, the next word was Paris, the correct word was Paris. So how much different is Paris from electronic? If it came out to be too different, then it would try to change the different values in the system, in this whole matrix, and again perform this whole process to obtain some other word, right? And if that came out to be right, then it would appreciate this change that we have made, and it would keep it so. If again it came out to be wrong, then it would go back and change once more a few combination of the numbers, and this process takes place millions and billions of times, again and again and again, until the matrix that we have is really efficient. So this is how it has been trained. Now, is there just one matrix? No. What happens is there are layers of matrices. So let's say there are more than 100 or so layers, right? So at the first layer, the vector that we gave was our original vector, which contained the list of numbers. Now this list of numbers could be very high. For, I guess, for ChatGPT 4, it is somewhere around 64,000. So this whole vector now goes into this layer 1. What does layer 1 has? Layer 1, layer 2, layer 3, layer 4, and so on. So what does this layer 1 have? It has a pre-trained matrix, a matrix that was trained at layer 1. Let's just hold on for a minute and try to understand. You will see how these there are different matrices at different levels. So it took the first word, the first list of numbers, then it was multiplied to a predefined and pre-made matrix which was already efficient enough to take any value or any list of numbers and produce the correct next word for it, right? So at this point it formed some new vector which was somewhat good, right? Then it went to the next level of matrix, and this matrix made it more efficient. So efficient in what manner? Let's understand. At the first this is not something that is predefined or done manually, but this is something that happens by chance. So what happens is, at the very first matrix we just try to create a correct word. After passing through this wall, this word that we have created, this v1, that the word that it corresponds to, the word that it has created, should be eligible in the English alphabet, if we are talking about the English language. At the next level, when it goes, always this matrix 2 that was created and that was efficiently made for this particular level, had gotten words that are already eligible and that were correct through words. So now it focused on creating words that were grammatically correct in the formation that it has gotten until that point of the sentence. So now here it tried to create correct words. At this point, the language or the matrix tried to create grammatically correct predict grammatically correct words. So after your an R should come and not is. So that is how this one was worked. Now at this point, whatever matrix would have been trained at this level 3 would have always gotten correct words in the English alphabet and would have always gotten grammatically correct words. So now it would try to produce context, for the language. So until and up till whatever it has gotten, it would try to create good relationships between the word that is there and the word that it is trying to predict. And that way, around hundreds of layers were there. So hundreds of predefined, efficiently made matrices are there, which create and which produce this final output of one vector, one series of numbers that corresponds to the whole vocabulary of English alphabets. And in that, the one that has the highest probability is being chosen as the next word after France. So France, and after that we chose is. So that is how it works. So for every particular answer that it produces, it tries to go through this whole method for each and every single word. It predicts the next word by this whole method of going through so many layers. Now in this, one beautiful thing that is context. Now the AI is just trying to predict the next word on the basis of some numbers it has, some matrices it has. That could not efficiently produce good ideas or good things, because a bank could relate to a bank which is where we get our money, and it could relate to a bank of river, right? There could be two different meanings for the same word. So now it has to also work in the context with which the person is trying. And therefore, here we have something called the attention factor. This attention factor is created based on all of the inputs that we give. So these words transform into vectors, not vector, different vectors. And based on the basis of these vectors, the values are analyzed and we create something. The mathematical functions are used to create something called the attention matrix or attention list of numbers. And always, these matrices are working while keeping this attention matrix in focus, right? So the next word created is checked with this attention matrix, and then it is predicted for us. And this is how these different models create and predict words. They take our prompt, they analyze it, and convert it into a list of numbers where each number represents some characteristic, and how close or far, or how strong that the connection to that particular characteristic is to that word. And this whole list of vectors, these numbers list is called vectors, is analyzed, and then it is passed through a huge layers of system, where a particularly predefined efficiently made matrix is present, which transforms it to some levels of correctness. And then at the very last we get a contextually correct word, which is checked with this attention factor. And this is how every single word for our responses is generated by artificial intelligences. So, if AI is only a predicting model which works on based on the inputs that we have given, the prompt that we have given to it, and the words that we have used in that prompt, if it creates that attention factor based on our input, then it is in our hands how the AI is responding to us. How amazing, how accurate, how logical, how well curated responses it gives is something that we can direct. And this is a really huge capacity that we have to make AI work like an assistant.